This video is about looking at two-sample hypothesis testing. Specifically, I have the problem that's dealing with flight cost from two different airports. Because airport travelers do often choose which airport to fly from based on flight cost, particularly if you live more or less equidistant between the two. So I've got some cost data in dollars for a sample of flights from the Nashville and Memphis airports. All right, I'm going to use a significance level of 5%, and I want to determine which airport is more costly. Notice some things. First of all, I have a null hypothesis that they're going to be the same. I'm going to have a two-tailed or two-sided hypothesis test because I am not coming to this problem thinking, oh, Nashville is more expensive, so is Nashville more expensive? I don't come to this thinking, oh, Memphis is more expensive, so my alternative is not Memphis is more expensive, but simply which one is more costly, Memphis or Nashville? So I've got a two-tailed test. I also have my null hypothesis taken care of because I want to find out if they're the same or different, so I am looking at a difference of 0 as my null hypothesis. Now, how do I know that this is a two-sample test? Well, it's a two-sample test because if I take a look at my data is here in terms of a group of data from Memphis and another group from Nashville. So indeed, I do have a two-sample test. How do I know it's normal versus, say, a proportion test or based on binomial? To do that, take a look at any single piece of data. Any single piece of data here is a number. Since it's a number, this is going to be a normal test. So I've got two-sample normal hypothesis testing. Okay. Well, what else do I need to know if I'm looking at two-sample normal hypothesis testing? Well, I need to know if I am going to assert that the standard deviations are known with certainty, meaning that I know the absolute true standard deviations from the population. Well, I certainly don't have that in this problem. So it's going to be estimated standard deviation, so I'm going to be based on a t-test. But I also need to have some idea whether I am going to assume that the standard deviations are equal or whether they are not. Well, I don't really know. So why don't I just use this data to do a quick peek here and look at these standard deviations. And there's a standard deviation for Nashville. And there's a standard deviation for Memphis. So those are my standard deviations. Well, they're pretty close, but I'm not sure I'm willing to state for sure that they're going to be equal. So I'm going to look at two-sample, normal, standard deviation estimated, standard deviation unequal. So now I've completely determined what kind of test I want to look at. All right, so now how do I actually do this? Well, to actually do this, I am going to either type in all of those annoying formulas, which is kind of a pain, or I'm going to install the analysis tool pack. To do that, go up to the Start button, the Excel options, add-ins, analysis tool pack, put Go and then OK, and it will install them from the original files that you have for Excel. Now I've already done that, so where do I find that? Well, I look under Data, over here on the right where it says Analysis, and then it says Data Analysis. So I click on that, and I scroll down until I see t-test, two-sample, assuming unequal variances. Click on that. Now what I need to do is simply fill this in. I've actually already done that, so I've got variable range here. Notice that my variable range actually includes the title for Memphis, variable range for Nashville, there it is. Hypothesis mean difference. Well, my null hypothesis is that they're the same, so my hypothesized mean difference is 0. Since I have the labels Memphis and Nashville in there, I have clicked labels. My alpha is my significance level of 5%. My output range, that's where I'm going to have Excel put my results. I'm going to put it there in F13. So let's click OK. There is pretty much everything we need to know. Now, Excel did not ask us whether we were doing a one-tail or two-tail test. I set this up and thought it through and decided I already wanted to do a two-tail test. So I'm going to limit looking at this. Now, how do I actually do? Look at this t statistic and compare it to my critical value. Well, I'm doing a two-tailed test, so I want to compare my t statistic to this critical value. To compare those, obviously the t-stat in this problem is smaller, and I have a situation where I'm going to accept the null hypothesis. I really don't have enough evidence to suggest that these are different, even though if you look up here, it certainly looks like Memphis is more expensive. The average for the Memphis data is $335, whereas the average for Nashville is $259. But the data is simply not strong enough for me to be able to say that Memphis is more expensive than Nashville. So, okay, it looks like I'm going to accept the null hypothesis here. Additionally, I can take a look at this p-value. When I look at the p-value, my two-sided p-value is 0.08. That's larger than 0.05. Accept the null. So far so good. I've accepted the null. Looks like I am going to be able to make the conclusion there is no difference in cost between these two airports. Oops, airports. Okay, so there's no difference in cost between the two airports. Oh, really? Okay, well, is that really true? Well, I was treating this data like this is just a selection of flights to anywhere. So, I mean, I could have been picking up, this flight might have been the flight from Memphis to New York City, whereas this might have been the flight from Nashville to Atlanta. So I was looking at these as two just entirely different sets of data. But what they really are is that each line or each observation is a different destination. So this first line here is Memphis to Chicago O'Hare or Nashville to Chicago O'Hare. Now which one looks cheaper? Well, now what I have is what's called paired data. So having paired data, I actually am going to treat this differently because I'm going to look at the difference between the two. So to look at the difference, I'm going to take Memphis, subtract off Nashville, and there I now have a difference for the Chicago O'Hare. Go down and copy that in. So now I have these differences. Specifically, I can now look at the mean difference, which is average, of this group, and the standard deviation from this group. Well, okay, the mean difference is $76 and about 38 cents. But now that I have my data set up like this, I can actually do a paired test. That paired test is actually the same as doing this as if it were simply a one-tailed or a two-tailed one sample t-test, as if this original data didn't exist. So it's kind of the equivalent to having that data no longer exist at all. What if I were to make that orange so it looks like it doesn't exist anymore? We'd only be dealing with these differences. Well, now how do I want to do that? Well, this is clearly a t-test because I'm going to use an estimated standard deviation. And I can calculate out a sample t here. And to do that, I use my difference minus my null. My null is still 0. Divided by my standard error, where my standard error is the standard deviation, divided by the square root of n. Well, how many observations are there here? 1, 2, 3, 4, 5, 6, 7, 8. There are only 8 observations in this difference data set, so the square root of 8. Okay, so there's going to be my t-test. Well, all right, but is that t strong enough to reject a null hypothesis of no difference? To do that, we need to look at the good old t-table, and I can look at the t-table with the best of them, but you look for n-1 degrees of freedom at a two-tailed test, which means I need 0.025 in each tail. And I will find a significant t here by going to look at my t-table. Or I could go ahead and use that data analysis pack and ask Excel to do this for me. Because if you take a look, here's paired two sample for means. And now what have I got? Well, I'm going to want my two groups of data. The only restriction here is that make sure that the data is picked up so that each row is a single flight destination in this case. In other words, a single thing being tested twice. Single destination in this case, getting a price from Memphis and a price from Nashville. My hypothesized mean is 0. I did indeed pick up the labels. I'm looking at an overall significance of 5%. How about for an output range? I pick this up and I decide to ask it to say put the output right there. Okay, and there it is. Now, notice what's here. Notice that the t-stat that it calculated happens to be exactly the same as the t-statistic we calculated. So, woohoo, we did it right. What Excel does for us is it goes off and finds the critical values. Since this is two-tailed, I'm comparing this to 2.36. Well, 2.38 is not much bigger than 2.36, but it is larger. So I am going to reject the null hypothesis. However, you can't just stop with that kind of statement. The null hypothesis here is rejected, meaning that they're not the same, but I haven't answered the underlying question, which is, which one's more expensive? Because if you just pop your head up and say, oh, those airports don't have the same average cost for flights, and then walk away, people are going to look at you really strangely. In other words, you need to finish your conclusion. Finishing your conclusion is saying, all right, if I've rejected the null, what does that tell me? Well, in this case, what it tells me is that this difference here is positive. Well, how did I define my difference? My difference was Memphis minus Nashville, meaning that Memphis is more expensive. So I've rejected the null hypothesis, and Memphis is more expensive. Okay? So that's what we do. Now, what was the point of this? The point of this was suggesting that if your data is actually paired, take advantage of that, because you'll have a smaller standard error with paired data than you do with just plain two sample data. Because after all, you're taking advantage of using the same destinations. So when your data can be paired, collect it as paired data and use it as paired data. If your data is not paired and it's just basically two sample data, you will have quite large standard errors, and you'll end up with fairly low significance on things, meaning that you won't be able to determine if there's actually a difference. So that's what we needed to do, and that's what we did.